Hello folks, fellow YouTubers and friends. I've made mention a couple of times about a double Becket that I wanted to make in order to pull the chain to turn the generator on the two-stage oscillator. I've got it finished all, but I need a little clip right here. It wants to bounce a little high, but it works fantastic. Better than I imagined, actually. Simply, it moves up. It pulls the chain up. It moves down. It pulls the chain down on the other side. It moves up. Pulls the chain. Moves down. Pulls the chain. Moves up. Pulls the chain. Whoops. Got a bad link. I don't know what to do. But anyway, there it goes. Whoops. That's how it works. Now, let me see if I can back up and let you see it actually turning the wheel, which will be the generator in future videos. There you go. Take a look at that. Let's see if I can get the Becket up high enough where you can see what it is. It actually works a little bit better than the ratchet wrenches. The ratchet wrenches on the last video have a lot of play in them. Okay? This is very, very little play. I mean, when you start up, it instantly grabs the chain. When you start down, it instantly grabs the chain. It doesn't move an eighth of an inch in either direction without pulling the chain. So the slightest movement moves the chain. Or long movement. Okay, now I think I'll bring the camera over here, try to shoot down in here and show you how this thing is working. Okay? Alright, hold on. Here we go. I got the camera on tripod so that we can move it around a little better. Okay, let's see if I can get in here. Got to get a different position. There we go. Okay. All it is just a little cam right there. If I can get my fingers in here. And that cam catches. And this cam is bouncing up too high. All I need to do is put a little stop right there and it'll be fine. The one on this side, this is the one that pulls up, so consequently when the cam comes down, it catches the chain. Let me get around to the other side, see if you can see that. There it is. There it is, right there. Okay? It really works great. Fantastic. I can't wait to mount it. Alright, let's step outside and take a look at our new pendulum that we've just built. Got a little different design to it. The old pendulum with two coffee cans soldered together, and here we go. Alright, let's set the camera up so we can see what's going on here. Kind of bright out here. I hope this takes. There we go. Yeah, I see the shape of it is totally different. It's like a double-bladed axe, but there we go. But the size, and it's hollow right now. We're going to fill it with either steel shot or lead. With steel shot, right now the whole entire apparatus weighs 88 pounds. Steel shot, from the size of it, would add approximately 150 pounds more, and lead would add about 216 pounds more. So we're going to wind up with in excess of 200-pound pendulum, or pretty close to 300, depending. Well, with the steel shot, it'll weigh real close to 200, maybe a little more. Yeah, about 230. With the lead, if we melt lead and pour in it, it'll weigh about 300 to 320 pounds. So that ought to give us a little bit of a little bit more power. Plus, now with the two coffee cans, they were 6 inches wide and 12 inches tall, giving a total surface area of swinging through the air of 72 square inches. The dimensions on this are 4 inches wide and 9 inches tall. 4 times 9 is 36, so that gives us exactly half of the blunt wind drag. But there again, we've got this double-bladed axe system, which should cut through the air a little better. So I'm thinking, hoping we've reduced the air friction by over 50%. Well, number one, the two arms right there, they're only 1/4 inch wide steel, so that's 1/2 inch wide. The CRC cold roll channel, we had it swinging on in the last couple of videos, the other pendulum. They were each 1/2 inch wide a piece, so that we reduced the air friction on the arms by 50%. We've reduced the blunt surface area traveling through the air by exactly 50%, and we've decreased the air resistance by the actual shape and design. I'm really hoping that we've done some good here. Okay. Okay, that's about all I can give you for an update now, other than that, the fact that the pivot point of the power bar on the old pendulum is the front axle of a bicycle, and I'm really scared that we've used it so much, metal fatigue and so forth, that I'm really scared to hang 300 pounds on it and start swinging it. So I've bought some heavier bearings and some tool steel rod, what they call drill rod, and the drill rod's got a shear strength on it of about 24 to 26,000 pounds, so it should be able to handle just about anything I want to put on it. The bearings that we've bought are capable of handling 10 to 12,000 pounds of force each. So again, we're trying to build this thing as safe as possible. I've got to order some case hard bolts for it to bolt the bearings in so they don't shear off. But we're doing pretty good. We've got some 8-inch light duty I-beams. Let me see if I can find them in here. I got the sun at my back. I can't see hardly anything. Yeah, there. There they are. There they are. Well, anyway, we're going to use the 8-inch light duty I-beams to build the new power bar with. And anyway, there you go. We get started on the new power bar, I'll update you on that. Thank you, sir. Y'all have a great weekend, what's left of it. And by the way, it's after Thanksgiving. I hope everybody had a great meal and a great Thanksgiving and shared some time with your families. Goodbye.